Hi, I'm Gregory Mazza, and today we're going to be focusing on Module 2. More specifically, we're going to be looking at naming organic compounds with multiple functional groups. We're going to start off by looking at the functional groups, as well as naming functional groups as substituents. We're then going to do a couple practice questions, and we're going to finish it off by looking at some of the applications of organic chemistry, as in organic chemistry molecules and compounds that show up in everyday life. First off, we're going to look at the priority list of functional groups. This was covered in the lecture material, so I'll only briefly go over this. The key ones I want to focus on are carboxylic acids, so we can see that here. So carboxylic acids are going to have an oxygen double bonded to a carbon, as well as another oxygen bonded to that same carbon. It's almost like if an aldehyde and an alcohol came together. We're also going to look at amides, so that's when a carbon is double bonded to an oxygen, but instead of having an OH bonded to that same carbon, like a carboxylic acid, this time we're going to have an NH2 bonded to it. And the final thing I want to focus on are aldehydes and ketones, which are right here and here. And the difference is the aldehyde is going to be bonded, the double bond oxygen to the carbon is going to be at the end of the chain or the start of the chain, whereas the ketone is in the middle of the chain. And just a reminder that these R's here represent the rest of the carbon chain. So we can see on the aldehyde, it's an H because there's no carbon chain on that right side. However, with the ketone, there's a carbon chain on either. We're going to be looking at rules for naming groups as substituents. So we're going to see a very similar diagram to the one we saw on the last slide here, except we also have substituent name attached to it. So a functional group will be named a substituent if it is not the priority functional group in that compound. The ones I want to focus on are ketones. So when a ketone is not the priority functional group, it's going to be called oxo. When an alcohol is not the priority functional group, it'll be called hydroxy. And when an amine is not the primary functional group, it'll be called amine. One functional group that was not covered in the last diagram that I like to go over is benzene. Now, benzene is a substituent when it is not the priority functional group and is attached to a carbon chain that is greater than 6 carbons. In this case, when benzene is the substituent, we call it phenyl. Now, we are going to practice naming organic compounds with multiple functional groups. My strategy for naming organic compounds with multiple functional groups is to start off by identifying the priority functional group, and then the functional groups acting as substituents by circling them. To start off here, we are going to circle the priority functional group, which is an amide. Now we know it's an amide because we have an NH2 bonded to a carbon, and that same carbon is also double bonded to an oxygen. We also have a substituent of an alcohol. Now we know it's an alcohol because we have a carbon bonded to an oxygen, and that oxygen is bonded to an H. Now that we know that we have a priority functional group of an amide and a substituent of an alcohol, we know to call this 3-hydroxypentane amide, as we have a 5-carbon chain, and the alcohol, which we call hydroxy when it's a substituent, is located on the 3rd carbon. We're going to practice naming organic compounds with multiple functional groups with a second example here. Once again, we're going to start off by circling the priority functional group, and then the 2 functional groups acting as substituents. So, we are going to circle this here, and this is a carboxylic acid. We're also going to circle our 2 substituents, which are chlorine and an alcohol. The chlorine is on the 3rd carbon, and the alcohol is on the 4th carbon. Now that we know what our functional groups are and where they are located, we can name this molecule 3-chloro-4-hydroxypentane-oic acid. So we're going to do one last practice question with naming organic compounds with multiple functional groups. As always, we're going to start off by circling the functional groups, starting with the one of highest priority, which in this case is the aldehyde here. There's also, for the substituents, a bromine, a chloride, and an alcohol. Now that we know all of the different functional groups in this organic compound, the last step is to see how long the carbon chain is. In this case, it is 7 carbons long. Therefore, we will name the compound 3-bromo-4-chloro-5-hydroxyheptanol. The final part of this presentation is that we're going to be focusing on organic molecules in our lives. The first one we're going to be looking at is pyruvate. For those of you who aren't familiar with biology or cellular respiration, pyruvate is essential in cellular respiration. It is made during the first step of cellular respiration, where one glucose molecule becomes two pyruvate molecules in glycolysis. Then, pyruvate is transferred to acetyl-CoA and pyruvate oxidation. From there, the acetyl-CoA is able to go through the citric acid cycle, and the citric acid cycle, once complete, will lead itself to electron transport chain, and that is where we generate ATP, and ATP gives our body energy. So pyruvate is a pretty important molecule. As I just mentioned, and as you can see here, pyruvate is an organic molecule. We're not going to be naming this molecule, however, we are going to be identifying the functional groups in it. Once again, we're going to be doing this by circling. The first functional group we have is a ketone. And the next one is a carboxylate. The ketone is here. And the carboxylate is here. Now, carboxylates are unfamiliar to us. However, they are just a conjugate base of a carboxylic acid. If this were to be a carboxylic acid, there would have to be an H attached to this O here. However, this is not the case, and therefore, since we are missing that H, we call it a carboxylate, as it is a conjugate base of a carboxylic acid. The next organic molecule that we're going to be looking at is aspirin. Aspirin is a painkiller, and it can be found in almost any pharmacy. It is used to treat headaches, cramps, cold, flu, and many other things related to pain. However, in order to take aspirin, you do have to be 16 and above. As we did for pyruvate, we're going to be identifying the functional groups in aspirin. As you can see to the left of my screen, this is the organic molecule for aspirin. Now, we can see that aspirin contains a carboxylic acid. It also contains a benzene ring. And finally, it contains an ester. The third and final organic molecule that we're going to be looking at is glucose. Now, glucose is the most abundant monosaccharide. It is a carbohydrate, and it is consumed in cellular respiration. As I mentioned before, glucose is broken down into two pyruvate molecules through the process of glycolysis. And in cellular respiration, glucose, which is a product, eventually yields energy. Now, glucose is also produced in photosynthesis. People often refer to as photosynthesis as the reverse of cellular respiration, and plants perform photosynthesis in order to make their own glucose so they can use it in their own cellular respiration. Finally, glucose is found in carbohydrates, proteins, and now we're going to identify functional groups in glucose. We can see that the glucose contains an aldehyde on the first carbon here, and it also contains many different alcohols. We have one on the second carbon, one on the third carbon, another one on the fourth, fifth, and sixth carbons. To summarize what we have gone over, we first looked at naming functional groups when they are the priority and the rules for doing so. After that, we looked at naming functional groups as substituents and how to do that. And we know that we need to name a functional group as a substituent when it is not the priority functional group. After this, we then practice naming organic compounds with multiple functional groups, and we use the circling method in order to help us keep organized, as well as help us get a good view of what functional groups were in each compound. After that, we looked at the application of organic chemistry and focused on everyday examples of organic compounds. We looked at pyruvate, aspirin, as well as glucose. Finally, we were able to identify functional groups in each of those three different everyday examples of organic compounds. These are my references. Thank you very much for listening.